at probability density functions to the next part. And it's going to bring in some stuff that you will have talked about in the past, things like the mean, median, and mode that you can see up on the screen. So what we're going to be doing is working out if we have a probability density function, can we suck out of that the information of what's the mode, what's the median, what's the mean. You'll notice there's one called the variance here. We're going to ignore that. We sort of calculate it anyway, but we're going to be doing the standard deviation is what we're going to use. But if you have a look at the formula there for those, they're almost identical. It's just the square root symbol for the standard deviation. So that's from the textbook. Next to that, in this section here, I've grabbed straight from your formula sheet that's given to you. Now, you'll notice perhaps there's a couple of differences, and we'll highlight them in a second. But the formula that you need, or most of them, are there, so you don't have to have them on your own cheat sheet. So just having a quick look, the mode, all right, is always the value that appears the most. So in this case, it's going to be the maximum, so the maximum of that probability density function. Okay, so you might need to find that. Probably in most cases you won't need to do that, but that's what it would be. Okay, the median, we know the definition of the median is right. All the data in order from smallest to largest, and go halfway through, right in the middle. That's the median. So if you have a look at the formula given there for this, you've got the integral. Okay, and it's the integral of our function. So it's the integral of our probability density function. And it says, well, we want that to be equal to a half, so the area is equal to a half. The value we're looking for is this m value that gives us that. Okay, the a is the starting value of the probability density function. This m is that, where is the median? So that's the median you're trying to find. We'll just practice that in a minute. The mean, what we would call the average in everyday language. Okay, we use this symbol here called mu to represent the mean, and that is given us by this function here. It looks very similar. It has the probability density function, the f of x there, but we're actually multiplying it by another x. Okay, so at this stage I'm not going to explain why. We probably don't really need to for it to do it. We need to better use that. Okay, so that's the formula. We're going to do the same work, but we're going to change the formula by multiplying it by x. Okay, the last one, the standard deviation, it gives you two versions of the formula. Okay, and there's reasons for using both. However, what I'm going to suggest, probably strongly, is that if we look at what's given to you from the SACE board, okay, it has it looks very much like this one here. Okay, there's a couple of little extra letters in there, but effectively it's the same one. The only difference that you can see, and I've written a little note to remind myself to point that out, is that it has negative infinity and infinity on the integral sign. Now the reason for that is this works for a normal distribution, okay, which is a probability density function, and we're going to come to them sort of after this bit. The special bell-shaped curve. Well, in the bell-shaped curve, the ends are infinity, negative infinity, infinity. Okay, so this is, most commonly we're going to be using it for that. However, we can use this for all probability density functions. And so from the textbook, it's given us an A and a B as the start and the end of that probability density function. Okay, so that's what we're putting in. This negative infinity and infinity is the start and the end of that normal curve. Okay, so let's have a look at using it. There have an example that we can follow a little bit in the textbook just to show you what's going on. So if we've got a probability density function, a pretty simple one, which is nice, just half x, okay, then it must be between 0 and 2 to make it a probability density function. A is check it, so our checks are that it is above the whole way, it's above the x-axis, so there's the first one ticked. The area, they've actually done it in two ways. They've worked out the area of that triangle by just using geometry. or they've gone through using integral. Obviously, both equal 1. Okay, so the area is equal to 1. It's a probability density function. That's fine. It then asks us to find these things. So the mode was the maximum value of this function in that range. Okay, and it's a straight line. We can read that straight off and say the maximum value was there at 2. So the mode is 2. That's the most common value. Should make sense. The median of the solution, the median is the solution of this formula here, which we were given already. Okay, so first thing to do is to go through, find the integral 0 and m. Okay, but it's important that it equals a half. Follow through the steps to work out what m was equal to. Now, because it's m squared, we get 2. Mathematically, m could be equal to plus or minus square root 2, but we know from our probability density function that the domain is only from 0 to 2, so the value must be between that. So the square root of 2 is the answer, not negative square root of 2. The next part is the mean, okay, and so this symbol mu, okay, is equal to from 0 to 2, so that's the range of this probability density function. It's x times by our function. So in this part here, instead of being half x, we've got half x squared. Okay, but then we just follow through, find the integral from 0 to 2, and we get an answer of 4/3. So you can follow that in the textbook, because I haven't gone through that. What I have done is changed or written another answer for C, because in the textbook they use, if we go back up to the top, they use this version of the formula here. And in fact, if you look at the textbook answer, you'll probably say, gee, that was probably a bit more straightforward. Okay. In fact, what they do is calculate the variance first, okay, and then just put a square root over that, give it the standard deviation. Now, that's what part C says, is to calculate the variance and then the standard deviation. So you see the symbol for the standard deviation there. The course really only talks about standard deviation, so we're not going to worry too much about calling it the variance. We'll just use the square root symbol and calculate what's underneath. So this, when you look at it, you'll probably say, well, this is probably not the best way to go about doing it, but I guess it shows you another, another way that will still get you to the same answer. So I've written the formula. It's a bit messy. There's a lot of stuff going on. I'll just try and focus in on some parts. So the formula that's just written directly off of the the formula sheet. What we put into here is important. We've got this value here. That's the mu. That's the mean. So that just tells us something. We cannot work out the standard deviation unless we've already worked out the mean. Okay, and so the question, asks us first to work out what the mean is. All right. Now that we've got that, all right, so we've got that from over here, 4/3, we can then use that to calculate this part. We couldn't do this without calculating the mean first. Okay, so the x is just an x, leave it as an x, okay, and we're going to multiply it by the function at the end. Okay, so plugging all that in, this stays as an x. Here's our take from here. Then our mean, we've already calculated, we plugged it in, it's 4/3. And the function is half x. So you can see it makes a relatively large sort of function that we have to deal with. Remembering we've only got limited rules that we can use to find integrals. So we need to expand that out. Okay, and so it's a bit messy. I'll put this file up, you can follow through, but this is sort of in the process of expanding, still expanding so that we get 3 separate parts, okay, before we try and do the integral. Then in the integral section here, we've, it's just plug all those values through. Okay, so you can have a look at that yourself. I'm not going to go through it and waste time on it. Then we're going to plug our 2 into our x positions and get these values, and when we put 0 in, well, we're going to take 0, so that makes it pretty easy. you can plug all that into the calculator, to get those to be quicker. But effectively, try and keep your answer as a fraction. Okay, so it's 2/9, the square root of 2/9, and then one more step. Really, we should say that it's the square root of 2, but we can break that down. I haven't written that there, but just to remember that that's the same as doing the square root of 9 over the square root of 2 over the square root of 9. Okay, and the square root of 9. Can't do anything with the square root of 2, but the square root of 9 is 3. So we can simplify it down to that point. Okay, so that's from the example. I thought we'd have a quick look at one other question to go through, and then have a go. It's practicing these processes. They do take a bit of time to go through. So question 3. This is from 8B2. I've done part A because it's just finding the A. All right, so you've done a bit of practice of that. You can follow through, to find A. We know that it's a probability density function. So the integral from 0 to 4 must be equal to 1. Go through the process and we get to A is equal to negative 3/32. So not a nice number, but it's a number. Part B says sketch a graph. Well, I've just grabbed that from the answer sheet, but you would do that in a calculator. You could do it on GeoGebra, whatever. Importantly, when I first did the question, I made a mistake. When I graphed it, it was down here somewhere, and so I knew straight away I made a mistake because it was in the negatives. Okay, so much nicer to see. Okay, well, from 0 to 4, we're all in the positives, so that's a good sign. If we haven't made a mistake, then the area within this space, the area should equal to 1 as well. So then just to go through the process a bit more slowly for finding the mean. I'm going to do the median. I'm going to leave the standard deviation. You can have a go at that yourselves. But finding the mean, so I've written the formula in there, all right, for finding the mean. So we know that it goes from 0 to 4 for this probability density function, and the function we are given is this function here, but we know what A is now. So it's negative 3/32, lots of x minus 4. So we're going to put that negative 3/32, okay, and it was x. If we look here, it was that lots of x, okay. Let's write it down in full. Sorry, we need to have let's put the x, let's write it in the right order. Sorry, I don't want to confuse the matters here too much. Keep it in the right order. So we've got the x that's coming from here, okay, and then we're going to multiply that by the negative 3/32 x, lots of x minus 4 dx. Okay, so I've just written it out in a bit of full so we can see it. But because we have limited integration rules, we're going to need to expand that out into some sort of bit easier to deal with. So let's firstly make that negative 3/32 x squared and x minus 4 dx. And then I'm going to do something that we didn't really talk much about in the integration section, but we probably should have perhaps, and it's going to make these questions a whole lot easier. It's certainly in the textbook, but it tells us that if we have a function, so we've got this function here, and really it's just these all multiplied together. This part here, this is a constant, okay? And so we can do this step, which actually makes life a bit easier. It just takes out that fraction to deal with. So it's still the integral, but we're actually going to put the negative 3/32 out the front as a multiplier. Okay, and leave the rest. And in fact, I'm going to jump a step and expand out that bracket to make it x cubed take 4x squared. Okay, so all of that with respect to x. So what I've done is just said, okay, I'm going to make it a little bit easier to deal with because I'm bringing out that negative 3/32. All right, so now I'm just going to deal with that by itself. So I'm going to do this integral. So x cubed becomes a quarter x to the power 4. we've got 4 on 3x cubed from 0 to 4, okay? And we've got that minus 3 over 32 out the front. We don't have to deal, we can deal with that at the end, okay? Which just saves a bit of maths. 32, okay? And we only really need to put the 4 in because when we put the 0 in, it's going to take 0. So I cheated and did this before just so that we didn't spend time me trying to make calculations. Okay, so we get to that point there by putting the 4 in, okay? And then that will nicely simplify out to being 2. Okay, so remember what we were calculating was the mean value of that set. Now, if I go back to my graph, just out of interest, looking at my graph, you can see it's a quadratic. Okay, you can see that it's nice in that the middle point there probably looks good, which that's nice. It's symmetrical. The mean is actually going to be the middle value at 2 there. Okay, now that's not always going to be the case because not all of our probability density functions are going to come out symmetrical, but this one it does. Okay. And then, look, just as a last one, let's have a look at finding the median for this one, which was the one where we need to say half of the values or half the values that we get should end up being below that middle line. Now, we already know what that answer is because it's a symmetrical shape. So it's going to be 2 again. All right, so we should be looking to get the answer 2. Now, a question could be in there, to say find the median. It's likely to be in a test to not say find the median. It would be to show that the median is 2. And so we will algebraically go through and show it. So what we're going to do is it's going to go from 0 to m at median. And we know that the function was minus 30. It was minus 3, wasn't it? Minus 3 over 32, lots of x, take 4. This one, remembering, we don't have that multiplying by x at the front. We're just using the actual the function as it is, like the probability density function. What we do have to do, though, is say that must be equal to a half. Okay, so therefore, I'm going to do the same step as I did last time and bring that minus 3 over 32 out the front. Saves me a whole lot of work. Okay, I'm going to expand out that bracket and make it x squared take 4x. Okay, with respect to x, and it's equal to a half. Really helpful now because this is really just a multiplier. So I'm actually going to bring that over with the half. Make it a whole lot simpler. So what we're going to do, I won't do that, so I'll just write this part in. So we won't touch this part yet. But what we're going to do is it's minus 3 over 32. So we're going to multiply by 32, and we're going to divide by 3, but there's already a divide by 2 there, so it becomes divide by 6, and it was a negative, so we're going to put the negative there. Okay, so negative 32 on 6. Now it's a much simpler integral to deal with, so I probably can jump straight in. And so we're going to go, right, well, that's a third x cubed. Now it's going to be 4 on 2, which is going to be 2x squared from 0 to m is equal to minus 32 on 6, so that's going to be negative 16 on 3. Okay, therefore, so we've got 1/3 m cubed. Okay, because what we're doing now is substituting our m into these two spots. Take 2 lots of m squared equals negative 16 over 3. We don't have to do anything with the 0 because the 0 is going to make everything 0, so that makes it easy. Most cases this is going to be true. You could get a probability density function that doesn't go from 0 to a number. It might start at 1 to a number or 5 to a number. Then you would have to do the other part. Let's multiply everything through by 3 because that makes it look a bit neater, 6m squared equals negative 16. Okay, and we can see we're actually at a cubic, which is a bit messy, and like I would just move it to that, and from that point there, I would use my graphics calculator. Okay, you don't need to try and factorize that. It does factorize okay into a single factor, a linear factor and a quadratic factor, but let's leave it. But on your calculator, when you get the results, what's important is that, one, if you're getting the median, they can only have, one value. Can't have two middle points. That doesn't make any sense. Okay, and obviously it must be within the domain. This is actually going to give you three values. Two of those values, however, are outside of that domain from 0 to 4. Okay, the other value is that the median, which we already knew, was going to be equal to 2. Okay, so if you graph that, find the roots. Two of those roots are going to be outside of that range of 0 to 4. Okay, they're not nice ones. It's like 2 plus 2 root 3 and 2 take 2 root 3. All right, so not really that very nice a question at the end of it, but that is the process to be able to find the median. I'll leave you to have a go at doing the standard deviation, following that process, and I'll put some questions up for you to work on. Good luck.